Hi Math 098 students, this is a review for section D of the readiness exam, and this is part 2. So if you haven't seen part 1 covers the first part of the readiness exam, so 1 through 7. So go back to the video, see if you can see part 1 for this review session. I will start with number 8. Of course, look at how many problems there are. There are only 10 problems, so you can only miss 3 and pass the exam. So always think about how many you can miss, so you make sure that you are passing before you leave out of that classroom. Give this your best shot. Number 8, it says, given the equation y equals -1/4 x plus 2, complete the following. So they're asking you whether the line is horizontal, vertical, or slant. Write your answer. Let me already give you some pointers. A horizontal or vertical line are special lines, and usually they are written x equals a number or y equals a number. So if you don't have x equals just a plain number, a constant, and y equals a constant, then your line is not horizontal or vertical. So this would be a slant line. Write your answer. Then it says, what is the x-intercept, if any? Write the ordered pair. What is the y-intercept? What is the slope? Graph the equation. So some good questions, graphing questions. If you know how to graph and you understand graphing and points, these are not hard questions. You just have to understand conceptually what they're asking you. So let's get started. Now, if you look at number 8 and you look at the equation for number 8, what form is that? That form is called slope-intercept form because you have your y equals mx plus b form, right? So off the bat, since they already put it in slope-intercept form, guess what? You should already know what the slope is, and you should already know what the y-intercept is. So off the bat, you should already know 2 of the answers to this problem, because in y equals mx plus b, the m is the slope and the b is the y-intercept. So already I know that my slope is -1/4, and you can write m equals -1/4 or just simply -1/4, and you already know the y-intercept. And it says write as an ordered pair. So ordered pair meaning parentheses and your x and your y coordinate. Okay, so for my y-intercept, what my y-intercept is, or the b, would go where the y is, okay, and 0 would be your x. So this would be 0, 2. So already I know C and D, and I only have to figure out where A, B, and E are, and we're done. So we're almost done with this problem. Again, one way that you can tell that this is a slant line is because you don't have y equals a plain constant or x equals a plain constant. So you know this is slant. But I will prove it when we graph. What is the x-intercept? So it turns out when you have the y-intercept, your x is always 0. So for the x-intercept, your y will always be 0. So it's opposite of what you think it is. So notice again, anytime you have a y-intercept, the x is 0. And whenever you have an x-intercept, your y is 0. Isn't that interesting? So since we know that the y would be 0, we can always plug in 0 for y in this problem to determine exactly what the x-intercept is. So let me erase. So for the x-intercept, we're just going to substitute 0 in for the y, and we're going to solve for x. So to get x by itself, we can subtract the 2 from both sides. That'll give us negative 2 equals negative 1/4 x. And to get rid of this fraction here, you can multiply by the reciprocal. The reciprocal is negative 4 over 1. So if you multiply both sides by negative 4 over 1, you can see everything over here cancels. You have x equals a positive 8 because a negative 4 times a negative 2 is 8 divided by 1 is 8. So your x-intercept is 8, 0. And the last thing we have to do is graph. Now, since our equation is already in slope-intercept form, you can use rise over run by first plotting the y-intercept. The y-intercept is 0, 2. So we can use the information that you were asked to give and use it to your advantage when graphing. So 0, 2 would be here. Notice that the y-intercept intercepts the y-axis. Go ahead and label your points. That's a good tip. 0, 2. And then since our slope is negative 1 over 4, we will rise over run. Rise in general means to go up, but since I made the 1 negative here, we're going to go down 1 unit. So you go down 1 unit. So from 2, if you go down 1 unit, you go to 1. So we're going to go down 1, but we're going to run 4 units. So since this is a positive number, we're going to go to the right 4 units. So from the 1, we're going to go to the right. 1, 2, 3, 4. And what you should do here is always draw a line connecting the dots. So don't just leave dots on your paper, or don't just leave the ordered pair and plot it. You also have to connect the dots. And I would suggest you use a straight edge. I don't have a straight edge here, of course, but I would suggest you use a straight edge. Put some arrows at the end of your line, which suggests that the lines are continuous. They never stop. And that's how you graph using your knowledge of the intercept and the slope. Now, you could have plotted points by first creating a t-table and plugging in values for your x. So, for example, y equals negative 1/4 x plus 2, I would probably plug in negative 4, 0, and 4 because of this being a fraction. And if I plug in 4 here, the 4s would cancel. So that's why I chose 4. 0 is always nice because it will eliminate this entire fraction. For example, if I plug in 0 here for x, negative 1/4 times 0 is 0 plus 2. 0 plus 2 is 2. Again, that's your y-intercept. So this is just confirmation that what we did before is correct because we see 0, 2. Alright, this looks like 4, 1. So we can always plug this in. Y equals negative 1/4 times 4 plus 2 to see what we get. The 4s will cancel. We get negative 1 plus 2, which is 1. So this is indeed 4, 1 here. And if we plug in negative 4, now if you look at negative 4, it looks like it's going in this direction right here, right? So let's try it. If we plug in negative 4, plug in -4, as you can see here, 4 goes to 4 one time, but that -1 times that negative will be positive. Positive 1 plus 2 is 3. So -4, 3. So it looks like this -4 is going towards 3, which is accurate, right? So you could have also plotted these points just by plugging in some convenient points into your equation, or points that are easier for you to calculate manually. Alright, let's go to the next problem. So the next problem is a special line. So as I mentioned before, we have x equals a constant. So when you have a situation like this is a line, but it's a special line. Special line. Here's how you would graph that. I always use x, y, and for x, as you can see, x equals what? X equals 6. So I have no choice but to put 6 under x, because that's what x equals no matter what. Now for y, we can choose whatever we want, right? You can choose whatever you want for y, but for in this situation, x equals 6. Now here are 3 points that you can plot. So 6, -1. Here, always label your points. That's a nice touch. 6, 0, and 6, 1. As you can see, this line, once we connect our dots, is vertical line. It's a vertical line. I always use a straight edge to see how messy that looks. I always use a straight edge or a ruler. So here we have points. We already graphed our equation. What is the slope? Now what you could do, if you don't remember what the slope is, slope is the steepness of a line. So for special lines, that could be a little different, because either for a special line your slope is undefined or the slope is 0. Now you could use 2 of these points and plug the points into the slope formula. We had a point 6, 0, and we had a point 6, -1, for example. We can treat this as our 2. We can treat this as our points, first and second sets of points, and put it in the slope formula, which is y sub 2 minus y sub 1 over x of 2 minus x of 1. And as you can see, we get -1 over 0, which is undefined. So when you have x equals a constant, the slope is undefined. So when a 0, and this is how you can remember, one of my students told me this is how he remembers, when the 0 is under the line, it's undefined. So that rhymes. So if the 0 is under the line, that's undefined. So definitely we have an undefined slope. And again, our graph look like this. Notice that it is crossing the x-axis here. So where it crosses the axes, that's called the intercept. So 6, 0 would be our x-intercept. Notice if this line goes on forever, it will never cross the y-intercept. So we have none. Alright, we do not have a y-intercept. We do have an x-intercept. Our slope is undefined. And obviously here we have a vertical line. Alright, let's go on to the next problem. Alright, we have 5x minus 2y equals 10. And identify whether the line is horizontal, vertical, or slant. Well, it's not one of those special cases where you have the letter y equals a constant or x equals a constant, so I know it will be slant. It asks for the x and y-intercept again, the slope. So what you could do, if you wanted to put it in slope-intercept, you could. Intercept form, you could. Or you could simply, you can use a t-chart or t-table. You can use slope-intercept form and rise-run. There are so many ways you could do this. Alright, I want to go with just plugging in, finding the x and y intercepts using 0 as a substitution. So I'm showing you a different way to graph right now using the x and y intercepts. So again, to find the x-intercept, substitute 0 for y. So we have 5x minus 2 times, I'm going to plug a 0 in, equals 10. Therefore you have 5x equals 10 divided by 5, x equals 2. So you have the point 2, 0. That's the x-intercept. So up here I can go ahead and put 2, 0. Remember, they said write the ordered pair. Make sure you write x and y in parentheses, separated by a comma. So 2, 0 is here. Notice that it intercepts the x-axis. Now, to find the y-intercept, all we have to do is do the opposite of what we just did. Alright, we're going to plug in or substitute a 0 in for x this time. So 5 times 0 is 0. Then we have negative 2y equals 10. Divide by negative 2. Y equals negative 5. Therefore, our y-intercept is, since we plug in a 0 for x, right? 0 here, comma, and since y equals negative 5, our y-intercept is 0, negative 5. That's here. So as you can see, we do have a slant line, but we knew that because this is not a special case. The y-intercept is 0, negative 5. What is the slope? Now, you can find the slope several ways. You could use those 2 points here and plug into the slope formula, or you can put this into slope-intercept form, or you could rise-run. For example, if I have to figure out the change from here to here, how many units did I go up? 1, 2, 3, 4, 5. How many units did I go to the right? 1, 2. So I went up 5. 1, 2, 3, 4, 5. Went to the right 2. So I rise 5, run 2. Alright, now let me put 5x minus 2y equals 10 into slope-intercept form so we can confirm our slope. This will cancel. We have negative 2y equals negative 5x plus 10. We're going to divide by negative 2. And it turns out that our slope is y equals 5/2 x minus 5. So indeed, our slope here is 5/2, or 5/2. Alright, this concludes the review session for Section D of the Readiness Exam. If you have not watched Part 1 of this review session, please go back and watch that one.